I'd like to talk about IP4. IP4 is an abbreviation for Internet Protocol version 4. In this context, Internet means inter-network. In other words, communication between two or more independent networks. The Internet, the collection of technologies you use to check your email or surf the web, it uses several Internet protocols. By far the most common Internet protocol is IP version 4. IP version 4 assigns an address to every machine on the network, and it is simply called an IP address. It is a 32-bit binary number. It's often converted into a more readable form for humans, so something like 192.168.1.1 is an IP address. It's just a different representation of those 32-bit binary numbers. When we write the IP address out in the 4 sections separated by periods, each section is called an octet. So we have 4 octets separated by 3 periods. The value of each octet can be 0 to 255, but we seldom see actually 0 or 255 used. In many cases, those are reserved for special purposes. So most commonly, we see the numbers between 1 and 254 used as each octet of the IP address. An IP4 address communicates 2 things. It communicates what network it is part of, and also which host on that network is using this address. A host would be any machine, any computer, any device that is part of the network. The left side of an IP address, in other words, the beginning of the IP address, always tells us about the network, and the right side of the IP address, in other words, the end of it, tells us about the host. So in the IP address 192.168.1.25, the network is 192.168.1, and the host is 25. It's not always that the first 3 octets are the network and the last octet is the host. It could be just the first octet, or just the first 2 octets is the network and the remaining part is the host. And we'll talk about that later in the course, how to determine which part of the address is the network and which part is the host. But the part that's always true is the left side is the network and the right side is the host. If we look at some different IP addresses and compare them, we would say that IP addresses like this are all on the same network because the network portion of the IP address is the same, the 192.168.1 network. And then we have 3 different hosts represented, host 25, host 9, and host 250. Some examples of IP addresses on different networks. We see 2 addresses with a much different network part of the address, and therefore these are on different networks. That doesn't mean the 2 machines can't communicate. It's actually very common for machines on separate networks to communicate, but that communication is a little more complex and involves more networking equipment. Machines on the same network do not need to go through a router in order to communicate with one another, but machines on different networks do in fact need to go through a router to communicate with one another. But in the end, the communication can be quite seamless, whether the machines are on the same network or on different networks.